Dear viewers, very good afternoon to all of you. On the initiative started by Punjab EduSet Society and Department of Technical Education Punjab, myself Sukhwinderpal Singh, Senior Lecturer, SRS Government Polytechnic College for Girls Ludhiana, is here to discuss about the topic multiple access techniques, which is under the subject of wireless and mobile communication in the course curriculum of 3-year Diploma of Electronics and Communication Engineering 6th semester. So, today we will discuss about the various multiple access techniques and its features and advantages and disadvantages, and what are the functions of each multiple access technique. First of all, what is multiple access? As the name indicates, the access by multiple. Multiple access is access by multiple, that a channel can be accessed by some multiple user. In case of communication, then it is called multiple access. So, here the various definitions or various features of multiple access are: to share the radio spectrum by many users. The channel shared with many users simultaneously, and the dedicated channel allocated to users out of full spectrum by channelization of the available resources. So, as we know that we have the fixed radio spectrum, and the time duration for communication is also fixed. So, if we have only one channel, that channel will use the whole spectrum for the whole period of time. But when we think of sharing this channel or increasing the number of users, then there must be some sharing, so that multiple channel can access into this communication. So, in the third point, the dedicated channel allocated to users out of full spectrum by channelization of the available resources. The resources are available in the form of time or in the form of frequency band. So, we have to channelization of these available resources, and this is the main thinking behind the multiple access technique. The types of multiple access techniques are TDMA, which is time division multiple access. Here the time is divided between multiple users. Then FDMA, that is frequency division multiple access. Here the frequency is divided into multiple users for their access into the channel or into the communication. Then the third one is CDMA, that is code division multiple access. Here full time and full frequency is used by each channel, and each channel is allotted a particular code, and the communication is done in this manner. Now, we will give the elaborated definition of each technique. First of all, FDMA, that is frequency division multiple access. Here each user is assigned a specific frequency channel. The whole spectrum, whole frequency bandwidth is divided into some small frequency bands, and these are allotted to a particular user, that this user will be assigned this band of frequency, and then another user will be allotted another band of frequency, and so on, and no other user in same cell or the neighboring cell can use this frequency channel. Only the specific frequency channel can be used by a specific user to which it is dedicated. So, here the signal interference is reduced because there is no use of same frequency by the other user. Here number of user is limited because the number of users will be equal to the total frequency spectrum divided by the frequency band allocated to each user. So, if we increase the user, the frequency band to be allocated, that will be reduced and the quality of communication will get low. So, number of users has to be kept minimum possible. Then TDMA, that is time division multiple access. Here a common frequency channel is shared by each channel, but for a short duration of time. So, here full frequency spectrum or full radio spectrum is used by every channel, but here the time is divided, each channel, each user is allotted a fixed time slot. So, for that short duration of time, each channel will share the common frequency channel or common frequency spectrum, and here only one user can transmit on whole radio spectrum, but for a fixed slot of time. Here only at a time one user's transmission will be there for on the whole radio spectrum for the fixed slot of time. Here quality of transmission is very good, but for short duration. So, here also the number of user has to be kept limited, because if the users are increased, then time slot will be decreasing, the slot of time will be going low and low with the increase of users. The third one is the CDMA, that is code division multiple access. Here all users share common radio channel for the same time. Here full radio spectrum is used for the whole the time by each and every user. So, this appears to be a very hypothetical, because we have studied TDMA and FDMA, that either time can be divided or either frequency can be divided, but in the CDMA there is no division of frequency and there is no division of time. Each channel in the particular radio spectrum can use the full radio spectrum for the full duration of time. Here the difference is each user is assigned a special code that reduces the interferences and increases the privacy. Here each user is given a special code which appears as a noise to the other channels, and it communicates in the full channel with the help of that code, and there is no interference of this channel to another and of another channel to this channel, and privacy is very much increased by this kind of multiple access, that is code division multiple access. Now, we will explain each technique separately one by one. First of all, TDMA, the time division multiple access, it is the channel access method for shared medium radio networks. It allows several users to share same frequency channel by dividing signal into different time slots, and users transmit in rapid succession one after the other and using his own time slot, and its good definition or its better definition can be as this. It can be explained: the use of whole channel bandwidth by each user for a fraction of time. This is the basic definition or the good definition of TDMA, that is use of whole channel bandwidth by each user for a fraction of time. This is how the time slots are divided. On the x axis there is a the time is given, and on y axis frequency is given. The slot 1, slot 2, slot 3, slot 4 are the time slots allotted to different users. So, here we are seeing that on the y axis the full frequency spectrum is being used by every user, but for a fixed slot of time. The first user is using the slot 1 time, then what the frequency spectrum is being used is the full frequency spectrum. Then second user is using the slot 2 time, and then the third user is using the slot 3 time, and slot 4 time is being used by the fourth user, and so on. And there is some guard band or guard time between each user, so that there is no interference or overlapping between one and another user. The features of TDMA are: here digital data and modulation is used. The handoff is simpler due to non-continuous transmission. The handoff, that is the handing over of or the transmitting of the call from one user to another user or one cell to another cell is simpler, because there is the transmission is not continuous. So, the handoff is simpler in TDMA. The cyclic assigned slots can be delivered on demand in dynamic TDMA. In case of dynamic TDMA, the cyclic assigned slot can be delivered on demand. The time slot can be given on demand, that at that time that user is required, then it can be given as per the demand of any other receiver or public, we can say. But in case of FDMA, this is not possible easily. And here the intra-cell interference is reduced, because each user is using the whole frequency spectrum. So, there is no chance of intra-cell interference, and the synchronization is high, but the cell breathing in this kind of technique is complicated. This is the frame of TDMA. For 1 second, if we can allot this into 5 users, the 1 second can be allotted into 5 users like this. For site 1, 180 millisecond is allotted. For site 2, 80 milliseconds are allotted. Site 3, 180. Then site 4, 280 millisecond, and site 5, 180 millisecond, and there is 20 millisecond guard band in each of them. So, the total becomes 940, and then 920, and then 80 second for the guard band. So, the total time is 1000 millisecond for one TDMA frame. It becomes full 1 second, and this is divided. So, total 1 second, that is 1000 millisecond, is in this form can be divided into 5 users for different time slots. So, in this time slot, in one TDMA frame, 5 users are transmitting their signal for from the whole frequency spectrum. The frame is a fixed time plan, where each VSAT, each satellite or each user has been allocated a predetermined portion of total time. As we have seen in the previous frame, This is the explanation of that. As I have already explained, site 1 is 180 millisecond, site 2 is 80 millisecond, site 3 is 180 millisecond, site 4 is 280 millisecond, and site 5 is 180 millisecond, and 20 millisecond guard band between each site. So, a total 1000 millisecond or 1 second frame has 5 sites. The advantages of TDMA frame are: it has flexible bit rate and opportunity for frame by frame monitoring of signal strength or bit error rates to enable mobiles or base station to initiate and execute handoffs. So, the flexible bit rate and frame by frame monitoring opportunity, it enable the mobiles or the base stations, mobile stations and the base station to initiate and execute the handoff between the various base stations. From one base station to another base station, handoff is easy due to this opportunity for frame by frame monitoring. The slots can be assigned on demand because the frame is a predefined time interval. So, slots can be assigned as per the demand of user or as per the demand of public, the subscriber, we can say. The bandwidth supplied on demand, bandwidth can also be supplied on demand. There is less stringent power control due to reduced interference, because the interference is reduced. So, power control is very less stringent or very less complicated. The disadvantages of TDMA frame: higher synchronization overhead is there, because synchronization overhead is required. So, it is higher side. For high data rates, equalization is necessary. Frequency or slot allocation is complex. The channel capacity is fixed, so new user cannot be accommodated easily, and the propagation time of signal from mobile station to base station varies with its distance to the base station. The propagation time of signal, that is the time to propagate the signal from the mobile user's mobile station to the base station, it varies with its distance to the base station. So, if the mobile station is away from the base station, the propagation time is high, and if it is near to the base station, then propagation time is low. So, this problem is its disadvantage of TDMA frame. Now, we will discuss about the FDMA, that is frequency division multiple access. It is the oldest scheme of multiple access. It was started in 1930 by telephone companies by combining multiple analog voice signals over one line, and here it was a use of FDM with FDMA. As FDM is the frequency division multiplex, and by combining multiple analog voice signals over one line was use of FDM with FDMA, and only one transmission is propagated over each channel at a time. The available spectrum is divided into separate channels, and each individual channel frequency being allotted to a different user. So, here the main definition or main elaboration of FDMA is the available spectrum is divided into separate channels, each individual channel frequency being allotted to a different user. So, the whole spectrum which is available for communication, it is divided into small separate channels, and every channel or each individual channel, it is allotted that small separate channel to each individual channel. So, each channel can or each user can transmit or communicate over its particular individual frequency for the whole duration of time. In diagrammatically we can show as in this diagram. Here x axis is frequency and y axis is time. So, we are seeing that as in the first user, this is conversation 1. So, this is total 30 kilohertz frequency. So, each conversation is of 30 kilohertz. So, whole frequency spectrum is divided into small individual channels of 30 kilohertz, and they will communicate or transmit for a full duration of time. The time is not divided here, as in case of TDMA there was division of time because we have shown time on x axis. Here the on x axis there is frequency. So, total frequency spectrum is divided into different small individual frequency channel. So, each user is allotted its particular frequency band. So, this is 30 kilohertz, then there is a some guard band is there, then again conversation second again 30 kilohertz, then conversation third again 30 kilohertz, and so on. The guard band is again there in between each of these users, but they are transmitting or communicating for the whole duration of time. The FDMA, it was used by the following systems in start: the advanced mobile phone systems, AMPS, which is the United States cellular system, and total access communication systems, which is the European cellular system. So, these both were using FDMA for their telephone systems, and it is for analog system only. It can handle only voice transmission, neither data nor fax can be used or can be transmitted in on the FDMA. So, but in start, as we have already discussed, that it is the oldest multiple access technique. So, when the landline telephones were used for the voice transmission, so the AMPS, advanced mobile phone system, and TACS, total access communication system, the major countries of the world, that is United States and in the European countries, they both were using FDMA in their telephone systems. This is the working of FDMA. Here again we are seeing that this is the 3-dimensional figure. Here the time, full time is given, but frequency is divided in into separate channels. The whole frequency spectrum is divided into separate channels, but they are communicating for the whole time. And each narrow band channel, because from this point to this point we can say this is a broadband spectrum or the full spectrum frequency spectrum or radio spectrum. So, by dividing them into small frequency bands, they have become the narrow band. So, each narrow band channel is allocated to a single user. So, this single narrow band is allocated to a single user. That user or that channel can communicate its data for the whole time. This is dedicated channel for the whole time for this user. As an example, we can say because in this case of multiple access techniques, as we can have an example of hiring a car or owning a car. If you are owner of a car, you the car is there for your particular dedicated use. Either you use that car whole time, or it is it remains idle in your home, in your garage for many time. But if you use a car on hire basis or on share basis, when you need that car, you take car, you go to do your work, perform your work, and then you come back, then another user can take that car. In that way, the people can have a very big car or very big vehicle in the same amount, because if there are 5 or 6 users and they are spending approximately 3 to 4 lakh each, then they can have a big car of 15 to 20 lakh for their use, but they will use on separate time, and that car we can say that that will be getting its optimum use, that will not remain idle. And but if we have to spend our own money, that is 3 to 4 lakh, then we will have a small car, but that will be dedicated for us, either it is idle or it is free or it is we are using it, we can use it at any time. But if we are on sharing base, then we have sometime we need car, but another user has taken that, then we have to wait or we have to give that demand, that is the on demand process. This is again how the available bandwidth is divided into different narrow frequency channel, and they are again each channel is using for whole time that for whole time that narrow frequency band out of the total frequency band. The available bandwidth is divided into number of narrower band channels. Each user allotted a unique frequency band. No other user can use same band. Each user allocated a forward link control as well as backward link control. So each user has its dedicated on forward link control and backward link control. So it can communicate forward as well as backward according to its requirement. The transmitting signal is analog in each of channel. Channel bandwidth is typical low as 30 kilohertz. So, like the example of car, the channel bandwidth is also low if we divide the whole channel bandwidth into, as we will have our own car of our own amount, that will be a we can say small car. So, the channel bandwidth is also typically low as 30 kilohertz, as a single channel is to be supported by a single user. So, most duplex FDMA systems transmit and receive simultaneously. So, this is the advantage that they can transmit and receive because they are duplex system. So, but the quality of transmission is not much good due to low bandwidth. Advantages of FDMA: it is flexible and simple narrow bandwidth is required. Each channel has its own block of bandwidth. There is continuous transmission, that is it can transmit at any time for the whole narrow bandwidth allocated to it. The framing or synchronization bits are not required because the channel is dedicated, and equalization is also not required as in case of TDMA. Disadvantages: the crosstalk causes interference on other frequency which disrupts transmission, because the channels are placed near to each other. So, there can be crosstalk which will cause interference on other frequency, and it is expensive, and it needs expensive and bulky duplex filters. There is wastage of bandwidth. Channel is assigned a bandwidth regardless of communication is there or not. Either as an example of car, either we are using that car for the whole time or not, either it is free or idle. So, similarly, if we allot a particular bandwidth to a channel, either it is transmitting or not, but the no other channel can use that bandwidth. So, there is wastage of bandwidth, and the another disadvantage, there is no other data transmission other than voice. Only voice transmission is possible through FDMA. So, as we require nowadays on mobile phones, everybody is using WhatsApp, Facebook and other internet services. So, most people are coming